CambiHub, and in today's video we'll be doing IGCSE 0478 Computer Science Chapter 4, which is Software. Now in this chapter we'll be understanding anything that is related to software, right? Now before we continue with software, let's clear this confusion. When we talk about a computer system has two parts, one of which is hardware and one of which is software. Now hardware, I hope you have already studied in chapter 3. We will be studying software in chapter 4. Right? Now when we talk about hardware, hardware is something which is tangible. So whereas software is something which is non-tangible or intangible. Right? When we talk about hardware are physical devices that we can touch. Right? Tangible means devices or something that we can touch. That is the meaning of tangible. So hardware is something that we can touch. A part of a computer system that we can touch, we can see, right? That is hardware. Obviously, when you think about it, the most obvious answer that what hardware is either your circuitry or motherboard or CPU or the processor. You guessed it right, that's hardware. When we talk about software, software is something which is virtual. Right? Software is something which is virtual. Right? Now there are two parts of the software, one of which is called system software. Right? One of which is called system software and the other is called application software. When we talk about system software, it is the software that is needed to run the system, right? That is used by the system, right? Which is your OS, your operating system. What could be an example of an OS? Obviously, we all use different kind of operating systems, right? Some of us use Windows, some of us use Mac OS, right? Some of us use in our mobile phone, some of us use Android, some of us use iOS, right? Some people also use Linux, Unix, right? Ubuntu, Kali Linux. So many examples are there of these of operating systems. Application software is for the user, that the user can use. So these are the two types of two types of softwares that we'll study. One of which is system software, which is used by the system to do its operations, and one of which is application software which is used by the user to do their tasks. Let's continue by getting deep into the chapter. Coming to the examples of system software and application software, when we talk about system software, right, obviously the first thing that comes under the system software is operating system that we have already discussed, right? Operating system, example Windows, Mac OS, Linux, whatever you want to quote, you can quote, not in the paper, just for your knowledge, right? Because in IGCSE papers, you're not allowed to quote any company's official name because that's their copyright, right? That's why you're not allowed to do that. Second thing that the system software has is the device drivers. Now when we talk about device drivers, these are small software files which allows communication with peripheral devices or with external devices that you connect in your system. Right? To understand device drivers, let's take an example. Suppose I am company A and I created a laptop today. But I know that there will be multiple devices that will be created in the future, right? And I want my laptop to connect to them, right? Obviously, if somebody is buying a laptop, they'll buy it for 4 to 5 years. And I, as a manufacturer, I also need to give support for at least 4 years of software updates, and support, right? So if a user is buying a laptop, they expect that in future, if there is a new device invented, which can be connected through my laptop, it should work well, right? Now, obviously, since everything is, software, everything runs on binary, the external device, which we call peripheral devices, the external device and my laptop, if they have to connect, they need to follow a set of protocols and they need to communicate. Without communicating, how would that external device connect to my laptop? But I, as a manufacturer, how do I make sure that, because obviously I cannot predict the future, what kind of devices might, might come in the market that I would want my users to connect to my manufactured laptop. So I don't know that. That's why there's this concept of device drivers, which are small software files which allows the communication of these peripheral devices with your laptop or with your device, right? And these obviously are available on that external device website, right? The manufacturer's website. Suppose there's a new kind of USB, so its device driver will be available. Now, Windows as an operating system used by most of the people in the world, 60 to 70% of the population uses Windows. Microsoft Windows, it automatically downloads these device drivers. As soon as you plug in a device, it automatically detects it. It detects its manufacturing code. It enters it on the internet by itself and looks for the device drivers. So this is another part of system software. Then we have utility programs, right? What is utility? Anywhere the user gets a use, right? However, they are a part of system software. A lot of people get confused that utility programs are part of application software, but no, utility programs are a part of system software. There are 3 types of utility programs in our syllabus. The first kind of utility program is disk defragmentation. Now, what does this program do? What does this application do? So over the time period when we store data in our drives, right? Obviously, we store data in our physical laptop, for example, we store it in our drives, we store it in our HDD, in our magnetic drives, right? We studied it in chapter 3, HDD and SSD. We store in them, right? Now, this is specifically for HDD, right? Now, over the time period, your data gets broken down into parts or into small fragments and it is all scattered over, right? This causes your system to slow down. Now, to fix this scattering over of data, what we do is we defragment the data, right? So data is broken down into parts, we sort the data, we defragment it, and this is done by a defragmentation software, right? This is to increase the speed of your disk, right? To increase the speed of your system, because your whole system is running on that HDD or Windows is installed on that HDD, and hence if that HDD is slow, your system is going to get slow. And that's why even when we buy a phone, right, over the time period it gets slow because of multiple factors. But one of the factors is when we keep on storing things on our device, it gets fragmented, and that causes a delay in accessing, or that causes latency in accessing, yeah, right? The technical term which you can write, which you will be writing in your paper and which will also be there in the marking scheme, is latency, right? The next kind of software is antivirus and anti-malware. I hope I do not need to explain this. However, you will study this in detail in chapter 5. However, antivirus is to prevent viruses and anti-malware is to prevent malware, right? What is malware? So malware is made up of 2 words, mal and ware. Mal is malicious and ware stands for software. So malicious software which we do not want in our system, right? Prevention of that, antiviruses and anti-malware. So this is all about system software. Talking about application software is something that we all use in our daily life. So application software is something that you would also be aware of. They have classified the application softwares. The first kind of application software is a spreadsheet. What is a spreadsheet? I hope you all have used MS Excel, Microsoft Excel, right? The green colored logo, the app which allows you to create tables, right? And a set of formulas, right? That is a spreadsheet. The next kind of application software is a word processor. Microsoft Word, Google Docs, everybody has used that, right? So that is the example for word processors. Databases, you'll study this in detail in chapter 10. However, databases allow you to, they have a similar interface to Excel, but they allow you to store multiple sort of data into tables and into different databases, right? And example for that is MS Access, the red colored one, the red colored cylinder, right? The logo, Microsoft Access. Internet browser, come on, everybody knows what a browser is. Mozilla Firefox, Google Chrome, Microsoft Edge, Internet Explorer, obviously it's shut down now. Then what? Safari, if you use a Mac, Brave browser, Opera GX, what else? Okay, I might have missed something. Do comment down in comments if I missed something, right? Games, I do not even need to give example for that. Everybody knows what games are, right? Even though there is an example written, Valorant, right? But that's just an example. You can quote any example if you want. And obviously not a company name because that is not allowed in your paper. I'll just get aside. If you want, you can take a screenshot of this. Okay, so before we move ahead, let's look at few more examples, right? So for application software, few more examples are, number one, a graphic manipulation software. What is a graphics manipulation software? One which manipulates graphics. I hope it's pretty it's pretty evident from the name itself. We can edit graphics, right? So one example could be Blender. I don't know if you have used the software or not. Just go and Google Blender and you can just see in the images what the software looks like, right? For photo editing software, obviously Adobe Photoshop, right, is one of the best examples. Illustrator and all of this stuff, right? Canva is also a photo editing and a video editing software. So video editing, DaVinci Resolve, KineMaster, what else? Animaker, and you can also get Filmora, right? There are many video editors. What is the Apple one? There's also a Mac exclusive, a pretty expensive video editor, right? That's also there, and there are multiple video editors. There's Clipchamp now in Windows, right? Right. So there are multiple video editors, right? And the examples are here. Then there's another kind of application software which is audio editing softwares. What are audio editing software? One of the best example is GarageBand or Logic Pro or FL Studio. These are called the DAWs. Also, a simplistic audio editing software that you can also use is Audacity, right? Now, when we talk about extra examples for utility software, backup softwares. What about backup software? For example, in Mac, to backup data, there's a software called Time Machine, right? And obviously there's another utility software, screensavers, pretty popular. What are screensavers? It's just that you can apply screensavers, right? When your laptop is idle, instead of going it black, instead of your laptop sleeping, going into the sleep mode, it will run some maybe a moving animation or something, or like just a timer or something. That's a screensaver. I don't know how it was earlier created to obviously for aesthetics and also to save battery, but nowadays it is only for aesthetics. It does not save your battery. Sleep mode is better, right? Because obviously if you have moving animations, it's going to consume battery, right? So these are some of the more examples. Let's move ahead to the next topic. Moving on to functions of operating system. So what does the operating system do? What are its functions? Let's see that. Number one, the operating system has a human-computer interface. See, we have a computer system, right? And we are humans, right? We as humans, we cannot process, okay, if I want to type hello, I have to type 100110110, right? We cannot use binary. We need some interface through which we can communicate with the system, right? So for that interface is called the human-computer interface, which allows us as humans, as users, to communicate with our system. In the earlier times, right, command prompt is a thing which is still available today. But in the earlier times, like during the time of MS-DOS, right, when earlier operating systems around 10 years back, like in those operating systems, 10 to 15 years back, 10 years back, we had Windows 7, right? 15 to 16, whatever, right? Long time back. In a computer system, everything was done using CLI. What is CLI? Command line interface. People had to type codes, people had to type commands to do tasks in their computer system, right? How stressful is that, right? So CLI. Nowadays we have graphical user interface. Windows, we call it web. In Windows specifically, we call it web. So we have graphical user interface, which allows the use of graphics, right? We have icons, right? We have icons. We have a specific icon for Windows key, for desktop, for Word, for Excel, for Chrome. We have specific icons. We have a mouse which we can move and navigate through those icons. So this is a graphical interface, right? This is graphical user interface. So this is the first thing that the operating system offers. Second thing is memory management. What is memory management? Number one, manages RAM and allows memory management of data to move between RAM and SSD during execution. So during our processes, as we know, a lot of data moves from the RAM to our internal storage, which is either SSD or HDD, right? SSD or HDD, right? Which moves from our RAM to our internal storage and from our internal storage to the RAM. This is also done by the operating system under the process of memory management. First thing, right? So memory management is all about managing memory. Second, keeps a track of memory locations. It keeps a track of several memory locations in the system, right? So this is its second point. 3, it prevents two operations from using the same memory location prevents system crash, right? There's a process A, there's a process B. Both of them use the same memory location of the RAM at the same time. This will cause the system to crash. So memory management also prevents that, right? It prevents a system crash by preventing two operations from using the same memory location at the same time, right? The next function of the operating system is obviously security management, right? Automatic system updates. System updates are necessary to fix bugs, glitches, and whatever, anything, loopholes in the system, right? Ensuring applications are up to date. Obviously, apps also need to be up to date that are there in a system. Maintaining access rights, right? So we have different users in a system, right? If you have a family laptop, right, there will be a user for your mom, for your dad, for you. So all of these three will have their personal files. So access rights are maintained, right? That my user files are not accessed by another user, right? Then system restoration. If something wrong happens with your system, you can restore the original system. And data privacy and or protection, right? Obviously, we need to we need to get privacy for our data and protect it, right? That is also done by the operating system under the security management rule. Then peripheral management. Obviously, we discussed device drivers, right? We discussed how device drivers are managed. Let's talk about buffers. So buffers are temporary memory, right? They are specifically, your book has given the example of printers, right? Which is relevant to the chapter. I'll also give you another example. So what happens is, whenever you want to send a document to your printer for it to print, that document is not directly sent to the printer. That document is stored in a temporary storage called buffer. And from the buffer, the printer takes the data and prints it. So why is this happening? Even if, suppose you shut down your laptop or something happens to your laptop, the document has been stored in the buffer. So the printer will take from the buffer and keep on printing. Suppose you give a print command, you want to take your laptop away to some other room in your house so that the printer prints the files till then. So that's why it transfers from your laptop to the buffer and then from the buffer to the printer. Another good example for this is YouTube, right? We all watch YouTube videos like you're watching one right now. Just do one thing, just hover over your mouse, just go to the place where you can forward and go backward in the video, the red colored line, right? The red colored line on the YouTube. Suppose this is my video, there's a red colored line, right? And there will be a circle. If you move this circle, the video is forwarded and backwarded. The video is, you can 10 seconds forward it, 10 seconds, rewind it. That's a different thing. But after this red colored line, you will also find a white colored line, right? You will also find that white colored line. Even if you, let's say your data signal lost or you turn off the Wi-Fi right now, your video will still run for a few seconds. But how? Right? Wi-Fi is turned off. How is a YouTube video still running for a few seconds? Right? So the white line, after the red line, this white line shows the buffer. So your YouTube video downloads to the buffer and then from the buffer it is played in your system. So even if you turn off the Wi-Fi, this white line shows that how much the video has been downloaded into the buffer and the red line shows till where you have watched the video. So suppose your Wi-Fi turns off, your video is running for a few seconds until this red line matches the white line, because this is the point till where buffer has downloaded the video. Now after that it will require internet, right? When this red line reaches this full white line, the new video will stop, right? So this is also a good example of buffer. Let's see few more functions of operating system. I'll just get aside. If you want to click a screenshot, you can. The next functions of operating system are file management. Obviously, your system is the one that manages all of your files, right? Number one, it maintains file name conventions. It maintains that there should be a specific file name. If you have ever named a folder in your system, or if you have never named a file in your system, you cannot use special characters like /, right? All of these file conventions is maintained by your system, operating system, right? Or your system software operating system. Then create, open, delete, and rename files. Obviously, you can change, you can do file manipulation, right? You can delete files, you can create new files, you can rename files. All of these operations are also under file management, which is offered by the operating system. Maintaining file directories, right? Every file has a location, every file has a directory, right? For example, if you have ever seen file directories, it goes like C users, username, then desktop, and then under desktop there will be a folder, under that there will be a file, right? All of this directly, this file location is also maintained by the system. Then ensuring memory allocation to each file. Obviously each file also needs a memory in my system, so it will allocate memory to each of the file, right? The next operation is multitasking. Obviously your system does a lot of multitasking in the background, right? So it can carry out more than one task at a time, and efficient allocation of resources. So it is allocating equal amount of resources to all the tasks in the background so that they can run efficiently, right? The system can do multitasking. Then file management of the user. Obviously we talked about user accounts, right? There's an administrator account which has all of the rights in the system. They can do anything with the system. There are multiple other accounts which are secondary accounts, right? Moving on to the next topic. Talking about how do applications run. Obviously applications are run by the operating system, as the operating system provides them an essential platform on which these application software run, right? Now how does your system operate, right? When you turn on your system, when you power on your system, when you click on that power button, what happens, right? What all happens in the system, right? What happens is, number one, when your system turns on, when your system is powering on, right, when it is turning on, right, that is called the process of booting, right? So how does the system boot up? When you click on the power button, what does this computer do is, the computer loads the part of the operating, because obviously we are turning on the system, so what should open? Windows should open, your operating system should open. So as you click on the power button, your system then loads the operating system's parts, right, the operating system's parts into the RAM, right? So when you turn on your system, the parts of this operating system is transferred to the RAM, right? And this process is done by bootstrap loader. What is the thing called that does this process? Bootstrap loader. And what is this process called? Booting up, right? If you didn't understand, pause the video, rewind, and then just go through it once again, right? Then the basic input output system, which is BIOS, right? What does the system do? It is a low level firmware. You do not need to know what that is. Just learn that it is a low level firmware as of now, because you will study this in detail in AS and A level if you take computer science 9618 at that time, right? It initiates startup and locates operating system on the storage devices, right? BIOS is also going to initiate this startup process further. Once the operating system is, some parts of the operating system is loaded into the RAM by the bootstrap loader in the process of booting, the BIOS is going to initiate the startup and load the OS into the storage devices, right? RAM does not store everything, right? The major part of the operating system is stored in our internal storage. So it will also run this operating system on our storage devices, right? This is the process of booting up. Now where is this BIOS stored? This BIOS is stored on a storage device called EEPROM. And how is this BIOS run? It is run by CMOS batteries, CMOS batteries. You just need to know this information, right? If you didn't understand, it's a pretty simple process, right? There's boot up, right? After boot up, the startup process is initiated by BIOS, and then it is stored in EEPROM where the BIOS can be edited and manipulated, and it is run by CMOS batteries. Now just for your information, this is not there in your chapter, but those who have a deep interest in computer science, have you ever seen when you power on your system, right? When you power on your system, the lights, if your keyboard has a backlit, right? If your laptop has a backlit, when you power on your system, right? Suppose this is my laptop, right? When you power on the system, this keyboard, right? The screen is turned off right now, but when you click on the power button, the backlight, the keyboard lights for a few seconds. Why does that happen, right? Whenever you turn on your laptop, your keyboard's backlight, it turns on for a few seconds and then turns off. This is when your system is checking each and every operation, each and every part of or a component of your hardware. The system runs everything and checks, is every part of the system working, and one of the part of the system is also the backlit of the keyboard, right? So that is visible to you, but internal also it checks if every component is working or not. So it also checks the keyboard, it turns on the light and then turns it off to check if the keyboard light is working or not. And if something is wrong, it will give you an error message, right? Let's move on to the next topic. Moving on to interrupts, one of the most important parts of this chapter, because if an examiner decides to give a question from chapter 4, it will be interrupts is a thing which is most likely to come in your paper. So what is an interrupt? Interrupt is a prompt or a signal which is sent to the operating system telling it to stop doing its task and service the interrupt first. So suppose if there is a high priority task which requires sudden attention by the operating system, an interrupt, a signal will be sent or a prompt will be sent to the operating system to service that interrupt, right? What could be an example of interrupt? So interrupt can be of two types, hardware and software, right? Suppose your system is doing a work, but due to some reason your system crashes and your memory runs out. So at that point of time, immediately there will be a prompt, there will be a signal on your screen that the system runs out of memory, that the system ran out of memory, right? So system running out of memory is an example of a software interrupt, right? Division by zero, we all know that according to mathematics, right? Obviously even my maths is not that good, but if your maths is that, even if your maths is also not that good, you probably know this, that if I talk about fractions, right? If I talk about P and Q and I want to divide P by Q, Q cannot be equal to 0. Obviously, it's obvious, right? So division by 0 is mathematically not defined, right? So when you divide by 0 on a calculator, an interrupt is generating, giving you an error message or giving you a statement which says it's not defined, right? This is a software interrupt. What could be an example of hardware interrupt? The simplest example in this world of a hardware interrupt is when you click on your mouse, right? Your system is idle right now, but as soon as you click on your mouse, an interrupt is generated. Or as soon as you click on your keyboard, an interrupt is generated, right? So a key press or a mouse click is an example of an hardware interrupt. What could be another example of hardware interrupt? Printer runs out of paper, printer runs out of ink, printer runs out of toner, right? Printer runs out of paper or printer runs out of ink. There will be an error message and your printing process will be stopped. These are examples of interrupts, right? Few questions that students get confused with. Number one, who services these interrupts? What is the name of that thing that services these interrupts? ISR, which is interrupt service routine. Interrupt service routine, right? Who handles these interrupt? ISH, interrupt service handler. Who will put the interrupts on priority? Okay, this interrupt is at this priority, this interrupt is at this priority, this interrupt is at this priority. Who will do that? Interrupt service handler, right? When is the interrupt serviced? When do we service this interrupt? The computer, once it finishes with a fetch decode execute cycle, or before starting with a new fetch decode execute cycle, at that point of time it will check for interrupts. For example, one of the fetch decode execute cycle completed. Now the next one needs to start. Before the next one starts, the system will check for interrupts at that time. So this is all you need to know about interrupts. Let's move to the next topic. The next thing that we are going to understand is IDE, which is Integrated Development Environment. Now we are talking a bit about coding, right? We all know what is coding, right? We know what is Python, we know what is Java, right? What is an integrated development environment? An integrated development environment smoothens your coding process. How does it do that? We'll look at the features of it, right? There are a few features that we need to understand, right? Before that, let me give you an example. So in Python, this is called Integrated Development Learning Environment, right? In Python, we call it Integrated Development Learning Environment. Example of that is PyCharm, right? You can Google it, see in the images how it looks like, right? PyCharm, right? Let's see these features. Number one, obviously, it is a code editor. It allows you to write a code, right? So it is a code editor. It has translators. What do these translators do? They allow you to convert your code from high-level language to low-level language. Right now, all of our code, right, we'll understand what high-level and low-level language is in the later part of the video. But high-level languages is more close to English words, right? Words which are more close to English, like Python. Python is an example of a high-level language. Why? Because it uses words like print, input, output, right? So these are high-level language words. However, a computer only understands binary, which is a low-level language. So these translators convert this high-level language, your Python, into binary, into low-level languages, into machine code, a code that your machine can understand. The next feature is debuggers. It allows you to fix your debugging in computer science terms. In technical terms, means fixing errors. So it allows you to fix errors, right? To run error diagnostics, to troubleshooting, to see what errors you have in your code. Autocorrection. Autocorrect. We use it on our mobiles, right? Sometimes we get irritated by that. We also have this in IDE. When we are writing a code, it gives us a grayed out version of a completion of that code. So that AI will judge what you are writing and it will give you options. If you click enter, it will automatically complete that section of the code, right? Auto completion, that is auto completion, which I just explained, right? It will automatically complete it. Auto correction is when you write something wrong, it is automatically going to correct it. Instead of writing print, you write print, PIRNT. Instead of writing PRINT, you write PIRNT. It will correct that, right? Pretty printing. What is pretty printing? Color coding. So your IDLE or IDE, it pretty prints your code. It color codes everything, right? All of the keywords, the Python keywords will be in a red color, or if you do something wrong, it will be underlined, right? All of this is pretty printing. Block minimizing is putting blocks to your code, right? Putting sections to your code so that you can segregate different parts. So these are the features of an IDE. Let's move on to the next topic. Coming to languages, we talked about that how high-level languages use English words and how low-level languages use binary, right? How to identify a high-level language, right? High-level language, obviously, Python, Java, right? These are high-level languages. How would you identify high-level languages? Where you see English. It's as simple as that. Where you see English, that is a high-level language. Now, what do you mean by English? Something like input, sum is equal to A plus B, print, sum. If you see code like that, this is Python, right? So this is high level language because you see English in it, right? Low level languages, machine code. How do you identify machine code? First of all, it is directly accessed by the system. So this is one feature of the machine code. Please note it down if you are making notes. Machine code is binary. How would you identify binary? Where you see 1 and 0s, different combinations of 1 and 0s, which boggles your brain, right? 1 0 1 0 0 1 1 0 0 1, something like that, right? This is how you identify machine code. How do you identify assembly language? Well, assembly language is something that assembler is the one that translates this assembly language into binary, into machine code, that you learn at AS level. But how do you identify machine language? Assembly language, it looks like something like LDD 110, STO, option. If you see terms like this, right? STO means store, LDD means copying that data of that address into a place. That is all something which you learn at AS and 11 if you take 961 at computer science. But this is what assembly language looks like. If you go to page number 167 of Hodder education book, you will find this topic there. They have specifically shown screenshots from a computer system to identify all of these things. But I have told you the basics, which will make your concepts clear and which are just enough to solve the past papers. Moving on to the next topic. Moving on to the next topic, which is understanding the difference between and the features of compiler, interpreter and assembler, right? We all know compiler and interpreter. Okay, we don't know. Let me tell you this. Compiler and interpreter translates high level language to low level language, right? Compiler and interpreter, they both translate high level language to low level language. Whereas when we talk about assembler translates low level assembly language to machine code. So it translates assembly language to machine code, which is binary, right? First point understood? What all do what, right? Let's talk about compiler. First of all, compiler creates an executable file. What is an executable file? We know Windows, if you have ever installed an application, the application, for example, if you're installing Chrome is installed as chrome.exe, right? EXE stands for executable. So it directly converts your code into a program, into an app. Wow, right? Then it is easy to share the code because since compiler creates an executable file, you can share it with anyone, you can share it with any computers. Reason being, because a compiled code, a code which has been compiled by a compiler, can be run into any system, right? Any system which does not even have compiler installed in them, the code which is compiled by compiler can be run into them. So that's why it becomes easy to share, right? Then it reads the code at once. How will compiler translate the code? It will read the code at once from top to bottom, right? It generates an error report. Compiler always generates an error report at the end, and compiler is generally used during the testing phase. Once a program is complete and we have to test the program, then the compiler is used. Coming on to interpreter, interpreter is not shareable. Why? Because interpreter requires, if you want to share a code to another computer which has been interpreted by an interpreter, you would need to install interpreter in that other computer also to run an interpreted code. So it is not shareable, right? Runs line by line. Interpreter, like compiler, runs at once. Interpreter runs line by line. And compiler is used in the testing phase, interpreter is used during the development phase when we are developing the code, right? Assembler also produces an executable file like compiler, and it is also shareable like compiler. So these are the three differences, and coming to the end of a chapter, let's solve one or two questions to give you an idea on how do questions come in the past papers and to check your knowledge. Okay, coming to the questions, if you can see the question here, we have the boxes here, right? There's a statement given to you. We have high level language, machine code, and assembly language. You need to tell which statement is true for which language and check mark the box, right? I'll give you a few seconds. I'll get aside, you pause the video, solve it, and then we'll discuss. Okay, since you have solved now, let's discuss the answers. The first question, the first statement says requires a translator to be processed by the computer. Obviously, a high level language needs to be converted, right? And assembly language also needs to be converted to machine code. Whereas machine code is binary, which can directly be understood by the computer. That does not need a translator, right? Examples of low level language. Obviously, examples of low level language will not be a high level language. It will be machine code and assembly language. Uses mnemonics, right? What are mnemonics? I told you LDD, STO, right? LDA, right? All of these things. They are used by, mnemonics are used by assembly language, right? Uses English-like statements. High level language uses English-like statements. Direct access to the system. Which one has a direct access to the system? Which code is directly accessed by the system? Machine code and assembly language. It is portable. High level languages portable, right? So these are the answers. I hope you have understood the video. Do not forget to subscribe to CambiHub, and we'll also put our community link in the description below, so you can join our WhatsApp community where we'll answer all your doubts. We conduct sessions, we have courses, we have tuition services, right? And we have a lot of free resources available. So do join. If you want notes of this chapter, right? All of this thing that I've explained here is there in our CambiHub notes, right? If you want, I'll show you a quick sneak peek of the notes, right? This is what our notes look like. All of the lectures that we explain, right? These are the notes, right? For chapter 5, if you can see, I've explained from these notes. If you want them, then do visit our website. The website link, right? The link for the website, I'm writing it here. It's also there in the description. www.cambihub.com is the website link, right? If you would like to work with us, then mail us at support@cambihub.com. If you want to mail something to me, like your doubts, right? Obviously the comment section is there. If you want to mail your doubt to me, you can either join the WhatsApp community and answer it there, right? You can message me. Or if you want to mail it to me, my mail ID is pranay@cambihub.com. PRANAY@cambihub.com. So that's it from my side. This is Pranay Arora signing off from CambiHub. I'll meet you in the next lecture.